indigo, and violet. Together these colors form what scientists call the visible spectrum. You can see these colors when a rainbow appears in the sky after rain. A rainbow forms when sunlight passes through tiny water droplets in the air and separates into different colors. This shows us that white sunlight is actually a mixture of many colors. Now something interesting happens when sunlight reaches Earth. Earth is surrounded by a layer of gases called the atmosphere. The atmosphere contains nitrogen, oxygen, and many tiny particles like dust and water vapor. Even though we cannot see most of these particles, they are everywhere around us. When sunlight enters the atmosphere, it does not simply travel straight to the ground. Instead, the light interacts with the tiny particles in the air. When this happens, the light begins to scatter. Scattering means the light spreads in different directions. Imagine shining a flashlight through fog or smoke. The light spreads and becomes visible from many angles. A similar process happens with sunlight in Earth's atmosphere. But there is something very important to understand. Not all colors of light scatter in the same way. Some colors scatter more easily than others. Light travels in waves, and each color has a different wavelength. A wavelength is the distance between two peaks of a wave. Red light has a long wavelength. Blue and violet light have much shorter wavelengths. Shorter wavelengths interact more strongly with the tiny particles in the atmosphere. Because blue light has a shorter wavelength, it scatters very easily. When sunlight enters the atmosphere, blue light spreads in many directions across the sky. When we look up, our eyes receive this scattered blue light from all directions. This is the main reason the sky appears blue during the daytime. This scientific process is called Rayleigh scattering. It explains how light interacts with very small particles in the atmosphere. Now you might notice something interesting. Violet light actually has an even shorter wavelength than blue light. This means violet light should scatter even more than blue light. So why is the sky not violet? There are two main reasons. First, the human eye is more sensitive to blue